Hello and good morning, doctor. So we are from Group 3 EMM3502 Instrumentations and Control. And the topic today is a PID control using Arduino system as a microcontrollers. So my name is Ong Junki and my matric number is 206902.
Hi doctor, my name is CHIEW matrix number 207997.
Hi, my name is Kam Jong Ho and my number is 206841.
Good morning, doctor. My name is Ken Shen, matrix number 206092.
Hi doctor, my name is KANG and my matrix number is 20698.
Thank you. So recently the people have developed a passion for gardening as a hobby to fulfill their daily life. So however, many individuals frequently forget to water their plants during the daily activity. Therefore, it becomes difficult for them to keep their plants healthy. Based on the above scenario, we decided that it is essential to implement an automatic systems that will take care of plant while considering all the various aspects of the home watering systems to help the plant grow healthy. And therefore, the goal of our project is to implement a simple automatic systems that utilize the Arduino not as a PID controllers and other components such as the soil humidity sensors and water plants. And I will pass to Shields.
Alright, so for my part, I will explain about the parts that we are using in this project. So first, we are having this microcontroller. We are using Arduino Uno as our microcontroller. So this is actually like the brain of our project, which taking the signal from the sensor and give signal to our actuator to respond to this system. Alright, so other than this microcontroller, we have soil moisture sensor as our sensor. So this will be sensing the moisture of the soil to send it to the microcontroller to decide whether we want to water the plant or not. So next we have water pump. This one is our actuator. So this is a submersible water pump which will be submerged in our water tank to pump the water to the plant. Alright, other than that, the other components that we are using is first this one breadboard, because we only have one output of the 5-volt power supply. So we are using breadboard to split it into two power supply for our relay and our actuator. So for our relay, this is actually our switch to control the on and off of this water pump. Other than that, we also have this module to take the signal from the sensor and transform it into a readable form by our microcontroller. And lastly, we have our power bank here as our power source so that our entire system is free from the socket and it is portable. Alright, next I will pass it to Juan to further explain about the working principle of this project.
Thank you, Chiu. So next I will be explaining about the working principle of this mechanism. So actually this mechanism is quite easy, where all begin with the sensor itself. As Chu explained, the sensor is for sensing the moisture level of the soil for the plant. And next it will transfer a signal, an analog signal to the module, and next will be the Arduino Uno itself, where the module will transfer the analog signal to a readable form. So you can read it and decided should it I send the output and decide whether it is a on or off for the relay. The output will directly send to the relay and next to the actuator. For example, if the sensor sensing the moisture level of a plant, of a pot or plant is high, we will send a signal to the relay where turn all the thing off, where the pump will not pump the water. And oppositely, if the water level is low, of course the Arduino will send a signal to the relay, make it on, and the pump will pump in the water to the plant. Yes, I think that's all. I will pass it to Cole to further explain about the circuit. That's right.
Hi, my name is Cole. So I will proceed with the wiring diagram and the component process. So as you can see on the screen right now, this is the parts we are going to use for our soil watering system. So this is the soil moisture sensor, this is the module, this is the Arduino Uno, this is the relay, and this is our pump. So the positive and negatives we are connected to the breadboard to let the jumper to connect to the ground system and the other to connect to the pump. So for this whole system, the soil moisture sensor will detect the moisturity of the soil and gives the signal to the module, and the module will transfer the will from the analog transfer to will transfer to the digital analog, and will give the signal to the relay, and the pump will start to work. So you can see that the red and black wire, which is the positive and the ground, will go to this wire and will come up with three different color. The purple will be the signal, so it change it detect the moisturity of the soil and give the data to the module, and the module will transfer to the data for the Arduino Uno to read. So the orange and green will come to the ground, and the voltage in, which is the green color, is voltage in, and from here the Arduino Uno also will give the signal to the relay. By the yellow is the signal output, and the blue is the ground, and this is the 5 volt. So because our power source is a 5 volt, so it will give it the power, and the module will the relay will start to act like the switch to let the pump start to work. So after that, when the power source is on, so the power source is connected to here, and the automatic plant watering system will start to function. Okay, that's all from me. Thank you.
Okay, so now I will explain about the coding of the Arduino. So when we look at the first line of the diagram, this is INT water, means that we need to set a variable for system with the name of water. And next we need to set out the system for the watering system. And the pin 3 output means that the number 3 output is responsible for sending the signal to the water pump. And the pin 6 input means that the number 6 input is going to accept the signal from the soil sensor to the Arduino. And the third step is we going to develop a closed loop. And so we can see if the water will be read the number 6 pin, which is coming from the soil sensor. And if the water is high enough, it will going to develop you can see the output number 3 we are going to assign a signal low. So it is to cut the relay, so no water will come out of the pump, and or else, which means that if the soil moisture content is very low, and you see from the code, the digital drive for the output will be high. So it will send a signal for the pump to pump the water and to moisture the same. So we set the delay for this loop for 5 milliseconds, means that it will sense the moisturity of the soil every 5 milliseconds. So that's all about the coding of the system.
Okay, so for now, we are putting this soil sensor into the soil to sense the moisture of the soil. Okay, so the pump is not pumping because the soil is quite wet. So when we remove it, okay, so it is dry because the atmospheric moisture is dry enough, so it will not. It will let the pump to operate and pump the water into the plant so that it is watering the plant. Okay, let's say it is wet enough, it is moist enough, and this sense the moisture, it will stop the pump. So the water is stopped now. Alright, so I repeat it again. When I remove it, the water will pump because it is dry. But when it senses the moisture in the soil, which is when I plug in, okay, the pump will stop. So it will start watering. So this is the automatic plant watering system that we are going to build. We have built. Alright.
So in conclusion, so in our demonstration just now, our project is considered successful. And we have used the microcontroller, micro sensor, Arduino, and other electronic tools to develop our system. And we have concluded our system is able to sense the moisturity of the soil. If the soil is dry, the Arduino will send signal for the pump to watering out the soil. And if it is wet, the system will stop lah. So basically in this project, we have learned how to use Arduino as coding to reach our objective of project. So that's all from us. Thank you.